470 light-years away, deep in the stellar ocean, lies a world remarkably similar to our own. It's invisible to the naked eye, but in 2015, the Kepler Telescope, designed to search for exoplanets, detected a faint rhythmic dimming of a distant star. It was a signal from a planet we now call Elsa. The name is unofficial, something we gave it to make this faraway world feel closer and more familiar. Elsa was discovered using the transit method. When a planet passes in front of its star, it causes a slight dip in the star's brightness. These light fluctuations allowed astronomers to confirm the presence of a new world. Elsa is located in the habitable zone, the ideal belt where life could potentially exist. This planet is nearly the same size as Earth and orbits a faint but stable star. Among thousands of discovered exoplanets, this one stands out as a top contender for the title of Second Earth. Elsa is a rocky planet with a dense structure and solid surface. Its diameter is about 12% larger than Earth's, and its mass is approximately 1.5 times greater. This gives the planet stronger gravity and geological stability. A year on Elsa lasts just 35 Earth days, and the orbit is almost perfectly circular, a factor that minimizes climate fluctuations. Gravity on Elsa is about 30 to 40% stronger than Earth's. It's a dense, balanced world, capable of holding onto its atmosphere and retaining heat. Elsa has a thick atmosphere that traps heat and shields the surface from stellar radiation. This helps create a mild, balanced climate without sharp temperature drops. The planet is covered with oceans, seas, and possibly rivers. Water here is not a hypothesis, it's a reality. Elsa has a full-fledged hydrosphere, supporting an energy cycle similar to Earth's. Scientists estimate the probability of life on Elsa at around 80%. Not Earth-like life, but rather a result of evolution under different conditions. On the bright side of the planet, organisms might harness the weak but steady light of the star. On the dark side, life forms could feed on chemical energy and the planet's internal heat. Their bodies, senses, and biology may be unlike anything we know, but they would have the essentials: energy, liquid water, and stability. Everything needed for life. Elsa orbits an M-type star, a red dwarf, one of the most common types in our galaxy. These stars are long-lived and dim, but stable. Despite Elsa's proximity to its star, conditions are not extreme. The planet doesn't overheat, and the star provides enough warmth. Elsa is likely tidally locked. One side always faces the star, while the other remains in perpetual night. But in the Twilight zone, where day meets night, the most stable climate could form, ideal for life. Elsa is already a focus of astronomical interest. In the future, new telescopes like the James Webb Space Telescope and other missions will be able to study its atmosphere, chemical composition, and possibly detect biosignatures. This planet is a priority target for continued observation. Elsa was discovered thanks to the transit method and the high sensitivity of the Kepler Telescope. By tracking subtle dips in its star's brightness, we can determine the planet's size, orbit period, and even estimate its density. These are some of the most advanced methods for finding new worlds, and Elsa is one of their most impressive results. Among the thousands of discovered exoplanets, Elsa stands out for its similarity to Earth-like conditions. Most worlds are either too hot, too cold, or lack a solid surface altogether. Elsa, however, combines optimal characteristics: suitable size, moderate density, a dense atmosphere, and location within the habitable zone. For this reason, it has become a benchmark planet, one that scientists use to compare new discoveries in the ongoing search for a second Earth. Average temperatures in Elsa's habitable zone are estimated to range from 0 to 30 degrees Celsius, especially in the transition belt between the light and dark sides. Thanks to its thick atmosphere and possible greenhouse effect, heat may distribute evenly across the planet. This creates stable conditions favorable to liquid water. However, the day side could be much hotter and the night side much colder if heat circulation is insufficient. Elsa's discovery is immensely important for science. It represents a major step in studying exoplanets, particularly those in habitable zones. It refines theories about planet formation, climate models, and the probability of extraterrestrial life. Elsa isn't just a point on the stellar map, it's an entire direction for future exploration. Among the many discovered exoplanets, Elsa stands out for its size, composition, orbit, location within the habitable zone, and high likelihood of having water. Elsa remains one of the few rocky worlds with Earth-like conditions. This makes it a reference point for comparing other potentially habitable planets. But this planet has a dark side, literally. Red dwarfs are known for their flares, massive bursts of energy, sometimes hundreds of times more powerful than our suns. Elsa may be subject to such bursts. If it lacks a strong magnetic field, its atmosphere could be partially stripped away. That would make life more vulnerable. But if a protective field exists, life could withstand even these harsh conditions. The story of Elsa is a story of hope. If life truly exists there, it proves we are not alone. And if not, we still gain priceless knowledge about the universe, about the potential of matter, and about ourselves. Elsa inspires us to search, to explore, and to keep going. Because somewhere, among the stars, others may already be looking up and dreaming, just like us. Elsa is just one name in an endless list of worlds, but it reminds us, beyond Earth, anything is possible. We're only at the beginning of this journey, and who knows, one day we may get there.